It's math time with Mr. Mock. It's math time with Mr. Mock. It's math time. Hey, Algebra. It's Mr. Mock. Wanted to do a video going over what yesterday's problem was all about. And the hardest part about scatter plots, which is what this is, you graphed a scatter plot. That's where you have a set of data that you've taken. In this case, we have the X and the Y. You take the data, you throw that information onto a graph, and it scatters all over the place because in this particular situation, it doesn't form a perfect line. Typically when we're doing research in the field, whether that's whatever you were doing research on, whether it's some sort of scientific, like social science research, where you're taking tally marks and you're just assessing people in the field and what they're doing, whether it is an actual experiment where you're collecting numerical data in another way. You take that data and you go to interpret it. And part of the interpretation is, for some things, when you're comparing two numerical values like we are here, you're going to put it on a scatter plot. Okay, so when you put it on a scatter plot, what you're looking to see, is there any correlation? Is there a relationship between the values? Do you see any type of trend, or can you make any type of conclusion, right? Is there a positive correlation where the data is increasing in a positive type of way? Is it a negative correlation? So there's a negative relationship. As one value increases, the other decreases. You're looking to see, is there any correlation at all? Maybe the scatter, you put everything on the graph and it's just like all over the place. And you're like, I don't see any type of relationship here, all right? And then once you have that relationship, what you're trying to do, and what we're going to do, is we're going to draw a trend line, okay? We're going to do the best we can to draw a trend line. As we get through the week and maybe into next week, we're going to have the computer, we're going to have Desmos do that for us and create a line of best fit, okay? And that'll be mathematically calculated. We're going to trust the computers to do that. Right now, we're just going to do the best we can and then kind of test and see how we did with our trend line, okay? And that's where residual comes in. Residual tells us how we did with creating our trend line. So the first thing we're going to do is, you're all listening to this, you kind of want to know if you had the right answer. The hardest part about this is just drawing the trend line, because there's no right answer. There's no like single correct answer. And that's really difficult, because you're like, I want to know, how do I do this? What if I'm doing it wrong? Well, you're only doing it wrong if you like don't follow the trend. Like if you totally are going in the opposite direction. All right. So let's start with, what does my graph look like? Okay. So this is the coordinates that I'd given you. The relationship was, X is 0, Y is 7, X is 1, Y is 4, 215, 324, 519, 727, 1038, and 1445, right? So I went and created my scatter plot, and I'm going to go ahead and zoom out a little bit so you can get a better picture here. So I went by twos on the y-axis. 2, 4, 6, 8, 10, and there's up to 20, 30, 40, and then 44, 45 being my highest number, right? And then I just went by ones down here along the x-axis. 1, 5, 10, 15, 14 being the highest number there. I even went all the way up to 20 because I had the room, right? So the first thing I'm looking to see is there any type of relationship with the data? And what we can kind of tell is, as the x value goes up, so does the y value. As the x value increases, the y value increases. Because of that, as the x value increases, the y value increases. That's a positive correlation. We're moving in that positive direction. We're going from left to right up, positive correlation. All right. And we can say that it's a loose correlation. I wouldn't say it's like super, like a tight, snug correlation. Like there's some space between things, right? We have a drop here, we go up, we have another drop. I mean, we're not like super tight to a line, but we know that it's following some sort of linear trend. Okay, there is a trend that we can see. Now, this is where I'm borrowing my kindergartner's ruler. Don't tell Hazel, okay? This is where we start now considering what is the line that best represents, where's the trend line going to be when we look at this, okay? And we're trying to kind of get an idea, right? As I'm going into the 20, as I'm going further into the 30, 40, where is that going to be based on what the trend is? If I do something like this, see how like this doesn't seem to be an accurate trend fit, right? Because now it's going this way, but these points are going a little bit taller, right? If I go here, that maybe is too steep, right? That does see like this, it's going, you're wanting to kind of just get a feel for where does this go? It's going to be something like in here, right? This is looking pretty solid. This is looking like it's a good representation. Now, if you came out and drew a line like this, yeah, that would be wrong. Okay, that would be kind of where you're wrong. If you were doing a negative correlation, I'm going to have to come out and just say, hey, you know what, you did that not correctly. All right. But honestly, what you're looking to do is just draw a line that represents what you're seeing. Now, I'm picking, and I typically like to do this. I'm a mathematician. No, I'm a math teacher. Okay. And I'm a dad. And what I found is that sometimes I'm looking for what makes the most sense. What's going to be kind of easy, because I know it's just a trend line. I'm going to use this to kind of predict future values. Now, see, if I draw this line here, that is going to be going maybe through two of the points. Maybe if I drop it down a little bit, I almost feel better dropping it down just a little bit. Maybe going from 6. I kind of feel better doing it this way, right? That's just me. And what I'm trying to do is I'm trying to like pick a couple points, have a couple intersections that I'm seeing. Like I'm seeing that I'm going to go through this point here, and I know what that one is. That is 735, right? 22, 22, 24, 26, 27, 27, 1727. Was that the point? Or 727 right here, right? That's that point. And then it's going to go through this y-intercept. That's going to make it a little bit easier for me. So what I'm going to do is I'm going to go ahead and draw the trend line. I don't want to use this pen though. I want to use something that's going to stand out a little bit. Maybe pink. Maybe pink will stand out. Let's take a look. So I'm going to draw the trend line this way. Now you might have drawn a different trend line. Guess what? That's okay. So long as it's following kind of what is happening with the data. And I would say, look, that's kind of following the data in a decent way. How do you feel about that? Like, I'm feeling pretty solid about this. I'm not feeling terrible. Now, if I go to write this point is at 0.6. This point here, I already said, is at 7.27, right? I have a y-intercept of 6. I basically just need my slope. So I already have the y-intercept. So I'm going up. Let's see, what did I say? 21. I'm going up 21 and over 7. Oh my goodness. 21 over 7. Isn't that 3? Kind of just going up. Look at that. 2, 3 over 1. Yeah, 3 over 1. 3. Ooh. 3 over 1. Oh, that's pretty sweet. I ended up getting a pretty, that worked out pretty much in my favor there, right? So what I'm getting for my slope is 3 over 1. My y-intercept is 6. And now I can use that information to write my equation. So that my equation for my trend line is y equals 3x plus 6. So then I can use that. I can use that to predict future values. so long as, my data maintains this trend line. Now, I can determine how strong this trend line is by looking at the residual, okay? Now, here's how the residual works. So hear me out. The residual is this space here. See this? I want to find that difference. So you're basically subtracting these y values. What's the residual here? This is residual. Residual here is a half. What's the residual here? Right? So you're looking at what is the difference between the known y value and your trend line y value. What is this distance, right? So in this case, what do I have? 2, 4, 6, 7, 8. 2, 4, 6, 8, 9. Sorry, I can count. So the residual here is 9. The residual here, 3. The residual here, 2, 4, 5. Residual here, that's pretty nice. This is just 1, right? So what you're doing when you're getting these residuals, residual here is 0. Residual here is 2. Residual here is 3. Okay? What you're doing is you're kind of trying to see, when I take those residuals and plot them back down here, are they really close to the x-axis? If my residuals are above and below, like it's scattering above and below the x-axis, but still close to the x-axis, like I still want my data in here, right? Then guess what? It's a pretty good line of, that's a pretty good trend line that you drew. If you have more numbers, like a lot more numbers up top, then it probably wasn't a good trend line. You want to have a good mix, right? So let's test and see what we did here, right? So here, trend line, what do I have? 1, so I could put a point like right here for 1, and I'm just going to do this in green. This is going to be, I guess, -5, right? So I'm going by 2s, 2, 4, that'd be -5. This one's at 3 above, right here. This one's at 9. Ooh, 2, 4, 6, 8, 9. That's like way up there. Okay, this one's at -2 here. So what do I've got? 1, 2, 3. That one's really high up there. I got 2 down here. This one's this one's just right on the line. This one's at 2 above. And this one's at 3 below. So now what I'm doing is I'm really just looking at, and I probably could have, I didn't have to do it this way where I had it like right following. I didn't have to do it like right where it's following the points, but I could have condensed and just been like the first one's here, second one's here, third one's here. So when I'm looking at these, I've got 1, 2, 3 below. I've got 1, 2, 3. I got a fourth one like way up there. This one's kind of an oddball. This one's looking at, we're going to be like taking, if we had like real data here, we'd be really thinking about what is this one all about. But for the most part, when I'm looking at this data, I've got one that's pretty, I mean, this one's 5, that one's 9. These two are kind of interesting. But for the most part, do you see how these points are close to the x-axis here? I would say that this is a pretty decent trend line, all right? Based on the residual, based on the difference between where the point is and where I drew my line, this is all pretty decently close to that x-axis. And I've got numbers above and below, so that's pretty good. So what that means is my trend line's all right. Now, what I'd like you to do right now is you're going to now take all this in. I want you to jot down some notes for yourself, but then I want you to determine your residual And I want you to kind of like see if you feel pretty solid about your trend line and what you drew. How's the residual look? Do you have more numbers on the bottom? Do you have more numbers on top? Do you have a smattering on both top and bottom? Is it pretty close to that x-axis? How does it look? And I want you to kind of just do that. So your objective today on On Demand Wednesday is you've watched the video. Now you're going to go and look at your graph and do the residual. Please, once you've calculated the residual, go ahead and click that you've completed this assignment. If you want to take a picture of your updated graph with the residual on it, or if you want to like recreate a graph with the residual, that'd be great, and just send that to me. That'd be fantastic. All right, team, that's everything. I know it's a longer video, but I think this is pretty cool information, stuff to think about as we're, working on with our algebra. All right, team, I'll talk to you soon. Bye. Okay, that's it. All done.